Okay, for day 2, we're going to talk about compound interest, which is a new formula, but all of the values that we talked about yesterday still have the same meaning. Okay, the A is for our total amount in the account, the P is still for the principal, the R is still for the rate, the T is still for the time in years. Now we have a new variable, N. N is for the number of times it's compounded. Okay, so number of times it's compounded. Some important vocabulary that we need to know is like, what does the N mean? Okay, so we're going to go through compounded daily. N would be 365. Compounded semi-annually, N would be twice, so 2. Compounded quarterly, think about 4 quarters in a dollar, N is going to be 4. Compounded monthly, there's 12 months in a year. Compounded weekly would be 52, we talked about that yesterday. And compounded yearly is just 1. Okay, so we're going to use these N values to help us figure out these problems. Okay, the first one, it says $5,000, so that's our principal, was invested for 7 years, that's our time, at an interest rate of 6%, so that's our R. Find the accumulated amount of the investment if the money was invested using simple interest. So yesterday we talked about this formula. Okay, this was our formula, so we're going to say 5,000 times 1 plus our rate is 0.6, our T is 7. Okay, so we're going to take this step by step and we're going to multiply on the inside, 0.06 times 7. Okay, then we're going to add 1. So now we've finished inside the parentheses, and then we multiply by 5,000. And we get 7,100. Okay, now we're in a compounded daily, so we're using this formula. So we are going to do same p-value. We have 1 plus 0.06 goes on the top, 365 goes on the bottom, and then 365 times times 7 goes in the top. So some advice, I would recommend taking care of this exponent first and figuring out what number that is. So that exponent is actually going to be 2,555. I know that's a lot. So my advice is rewrite this problem with your new exponent. It's going to be easier to put in the calculator if you know that number already. So if I want to put this whole thing in the calculator, I got to focus on parentheses. In my parentheses, I have a plus sign and I have division. I always divide before I add. So 0.06 divided by 365. Then I keep that answer in my calculator and I add 1. Okay, I keep that answer in my calculator and I'm going to raise it to this exponent. Remember, this is my exponent button, so I hit y to the x, 2,555. Then I hit equals. Okay, now I've done everything except this 5,000. That 5,000 out in front means multiply. So times by 5,000. So my total here is going to be $7,609.55. Okay, if you rounded earlier on in the problem, your decimal is going to be slightly different and you might be off by a few dollars. Okay, but if you kept your answer in your calculator, you should be getting the same thing. Let me just double check. Yep, okay. Next, we're compounded semi-annually. So set it up starting the same way, but now our n value is 2. So we have 365 to the second, or times 2. Sorry, 365 times 2. Oops. Nope. That is wrong. It's n times t. Sorry. So it's 2 times 7. 2 times 7. So when I do 2 times 7, that's going to give me a total of 14 as my exponent. So in my calculator, again, I'm going to do this part first. 0.06 divided by 2. I'm going to add the 1, and now I'm going to raise it to my exponent. My exponent's 14. Keep that answer in my calculator and multiply by 5,000. When I do that, my final answer is $7,562.95. Okay, compounded quarterly, 5,000. Set it up the same way. My n is 4, so now my exponent is going to be 4 times 7, which is 28. Okay, so steps in my calculator. Do the division first, add the 1, raise it to the exponent, so raise to the 28th, hit the equal button, and then multiply by the 5,000. So I've got $7,586.11. Compounded monthly, our n changes to 12. So my exponent is now 12 times 7. And when I do 12 times 7, I get 84. Okay, we're going to follow the steps. 0.06, divide by 12, add the 1, hit equals, raise it to my new exponent of 84, and then multiply by 5,000. So $7,601.85. Compounded weekly. And now my exponent's going to be 52 times 7. So my exponent ends up being 364. Okay, like I said, those are the steps I like to take to keep myself organized. 0.06 divided by 52, add 1. Now I raise it to my new exponent, hit equals, and now multiply by 5,000. And I've got $7,607.97. Compounded yearly. Yearly is just once. And now my exponent would be a 7. So 0.06. I could write divided by 1 in my calculator. I don't really have to. Add 1, raise to the 7th power, and multiply by 5,000. So $7,518.15. Okay, example 2. Example 2, Mikey invests in a savings account that applies compound interest weekly. So that's telling me my n value. How will his investment grow? Linearly or exponentially? Justify your answer. So we had two formulas. We had this formula for simple interest, and we had this formula for compound interest. If he is doing compound, we're using this formula. This formula has an exponent, so this is going to grow exponentially, not linearly.